Ba 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 ba! For the love of brew.
The process of brewing beer involves a few setup steps. The first is to combine a pre-made Pilsner mix, which consists of barley, malt, and hops, with boiling water. This forms a sweet liquid called wort. The second step is to pour this wort into a fermenter and add warm water so that the whole mixture reaches whatever volume of beer you want to brew. The last step is to wait for the mixture to cool to between 64 and 82 degrees Fahrenheit. At this point, you can stir in the yeast, close the fermenter, and let the beer sit for approximately 7 days.
Now the fermentation process begins. In this stage, the temperature must be held between 64 degrees and 82 degrees to allow the yeast to survive and the fermentation process to happen. To model how one might achieve this temperature control, we used an Arduino Uno with a TMP36 temperature sensor, a red LED light to represent a heating unit, and a DC motor fan to represent a fan that can cool it down.
For the cooling process, we decided to cool down the beer with a fan. When the temperature of the beer reached a point approaching 82 degrees, say around 80 degrees Fahrenheit, the Arduino TMP sensor would read this and kick on the fan, which would then attempt to cool the liquid down. After a certain amount of time, the temperature would then again be checked to see if it fell within the desired range.
The process for heating is very similar, except with the LED light. Now we're at the other end of the spectrum, and if the temperature approaches 64 degrees, say we're at 66 degrees, then the LED light will kick on and the same process will occur. A period of waiting will happen, and then the temperature sensor will reread and then decide whether the light needs to stay on or not to achieve the desired range.
The scene here is a block diagram that gives an overview of our control dynamic system. The input is the desired temperature range. The Arduino takes the temperature read from the TMP36 sensor, and at this point decides whether it needs to turn on the light to heat the liquid, turn on the fan to cool the liquid, or do nothing if this temperature is already within the desired range.
In the beer brewing industry, a much more advanced system is used to control the temperature. An initial PID controller monitors the temperature in a glycol tank. The glycol is then pumped through an outside jacket in the fermenting tanks. A second PID controller is used to determine the feedback of the temperature of the fermenting brew and the flow rate of the glycol that needs to go through in order to regulate the temperature. While both our system and this system use the temperature as an initial input, the brewing industry uses a much more controlled temperature response in order to get a much more desired temperature range.
The last step in the beer brewing process is to bottle the beer. First, 2.5 teaspoons of sugar are added to each empty bottle. This sugar reacts with the liquid, releases carbon dioxide, and thus carbonates the beer. Now, you can enjoy your beer.
Crisp like a rock.
So a brief summary to overcap this whole entire system here. We start off with a dynamic system with the Arduino temperature control. The input is continuous as the temperature is a non-integer and can vary within a specific range. The outputs to the system are either a heating unit or some sort of a cooling unit. In industry, they have many more different aspects that they control, such as pH level with salt addition as well. And then also, specifically, our system is considered an on-off controller, as it uses an on-off type feedback to regulate the temperature and turn on/off the devices.